Yesterday we talked about parallel and perpendicular lines. Today we're going to talk about a different pair of special lines, horizontal and vertical. So we talked about horizontal, vertical a little bit back when we talked about slope. So remember, horizontal lines go side to side horizontally, parallel to that x-axis. Okay, so horizontal lines are the flat lines side to side. When we talked about slope a couple weeks ago, we said that horizontal lines have zero slope, meaning they're totally flat. So remember, positive was increasing or going up. Negative slope was going down. Zero slope was completely flat. Like I just mentioned, they don't have an x-intercept. They run horizontal or parallel to that x-axis. They never ever cross the x-axis. Since these lines do not have an x-intercept, today when we are writing an equation of a horizontal line, there will not be an x in that equation. Okay, so no x-intercept, it's missing the x-intercept. Graphically, it's going to be missing the x in the equation. So essentially what our equation is going to be is just going to be y equals, and then whatever the y-intercept number is, it's just going to be y equals 5. Or like this one I just drew up here, this one crosses through 1, 2, 3, 4 through 4, so it'd be y equals 4. Okay? So let's look at this example. Let's graph it first. So it says graph the line that goes to the points 7, 2 and negative 5, 2. So 7, 2, 1, 2, 3, 4, 5, 6, 7, up 2. There's 7, 2. And negative 5, 1, 2, 3, 4, 5, and then up 2, back to the left. So there's negative 5, 2. Okay, if I were to connect those dots, obviously I'm going to be connecting them with a horizontal line going straight across. So this line is horizontal. We could see that graphically when we plotted the points. They were kind of even with each other, going straight across. The other way we could tell that this line is horizontal is if we take a peek at these points, the y values in the points are the same. Okay, it was 7, 2 and negative 5, 2. So when you notice that, when you see 2 points and you're like, hey, these two y values are exactly the same, this tells you this is a horizontal line. The equation of this line, y equals, okay, again, this equation is not going to have an x because it never touches that x-axis. And we're going to use that the y-intercept, which is 2. So it's going to be y equals 2. Now, if you also notice that 2 is the same numbers in the points. So if you weren't to graph this, you could just look at those points and get that y number, y equals 2. Okay? Now, vertical lines are almost exactly the opposite. Remember, vertical goes straight up and down. Okay, so there's a graph of a vertical line. Back when we mentioned vertical lines for slope, we called these undefined slope. When we did our slope formula, we ended up getting a 0 on the bottom of the fraction, which we said we couldn't do. We tried doing it in the calculator and it gave us an error. Slopes do not have a y-intercept. Therefore, when we go to write the equation, we're not going to have a y in the equation. Okay, it runs up and down parallel to that y-axis. It's never going to touch the y-axis. So the equation, when we write them, will not have a y in it. So this equation is just going to be x equals, and then whatever that x-intercept number is. Okay, so horizontal lines is y equals, and then the y-intercept. Vertical lines are x equals and the x-intercept. Okay, so let's graph this one. This one is 2, 7, so over 2 and up, 1, 2, 3, 4, 5, 6, 7. So there's 2, 7. And 2, negative 5, so over 2 and down, 1, 2, 3, 4, 5. 2, negative 5. All right, and now we can see that this line does run vertically through those points. Lines are not so great today. As good as it's going to get. Okay, so there's our vertical line. Notice that it's running parallel to that y-axis. It's not going to have it's not going to have a y-intercept. So it's not going to have a y in the equation, it's going to be x. Okay, this x-intercept is 2. So our equation of this line is going to be x equals 2. Now again, without graphing this, it says how else could we tell if this is vertical? This time, notice my x's are the same. And also notice our x's are 2. So not only is that y-intercept 2, but the points are 2, which is where we get that 2 from the equation. So if you were to look at these points and wanted to write an equation without graphing, you would just say, oh, those x's are the same, they're 2, x equals 2 for that vertical line. Okay, last 4 examples, there's a little mix of information that's given. So I want you to go ahead and pause this video and see if you can decide what kind of line is being described, so either horizontal or vertical, and then also write the equation of the line. So pause the video, try these 4 examples, unpause the video when you're done. Okay, number 1 with the undefined slope would be a vertical line. Since it is vertical, think about vertical not going through the y-axis. It's only going to have an x in the equation. And if you look at that x in the points, it's a 3. So our equation is going to be x equals 3. For number 2, m equals 0. 0 slope would be describing a horizontal line. Horizontal line side to side, only having a y in the equation. And if you look at the y point, 5. So our equation would be y equals 5. Number 3, if you look at these points, both of the y's are the same. So both of the y's, the x's are different. One's a positive and one's a negative, so those aren't the same. It's the y's that are the same. So this makes this a horizontal line. And our equation is going to be y equals, and then that one that matches. The last line is a vertical line. This time the x's match, -9 and a -9. So this is a vertical line, and the equation is going to be x equals that -9. Okay, so writing equations of horizontal lines and vertical lines are pretty easy. The problem with it is they don't appear all too often. They're very rare case of line. Most lines we have a slope, they slant either up or down. There's very rare cases where we're drawing a flat horizontal or a straight up and down vertical line. So we don't write these equations all too often, but if you can learn to identify these kind of specific cases or these rare cases, the equations are very, very easy.